Object manipulation with adaptive gains in virtual reality. Object manipulation is one of the most fundamental operations in virtual reality. The efficiency and accuracy of the manipulation directly affect the effectiveness of the applications. The traditional object manipulation method is to directly control the movement of objects in the virtual scene in a 1-to-1 ratio through hand movements, which causes low efficiency and low precision. One method to improve the efficiency of manipulation is to calculate the control display ratio based on the speed of the user's manipulation and manipulate objects in the virtual environment by using the ratio to scale the user's hand motion. However, due to the imprecise perception of the user's hand motion speed, the manipulation efficiency and accuracy are also needed to be improved. We introduce an object manipulation method based on adaptive gains in virtual reality. The results of the user study showed that compared to the previous work, our method improved the efficiency and accuracy of manipulation and virtual reality applications. We introduced the concept of manipulation gains and used the fitting function of visual metrics in the user's views to adaptively calculate manipulation gains in the process of object manipulation. First, we generate 2 auxiliary views based on the user's current viewpoint. According to these views, 3 object target visual metrics are calculated to measure the relationship between the manipulated object and the target: the projected area proportion, the distance, the angle difference. We design an experiment to obtain the maximum and minimum manipulation gains that the user can accept. In the task for maximum gains, the user is required to roughly manipulate the virtual object to the target position with a given gain. The initial translation gain is 150.5. Through visual feedback, if the user feels that the motion of the virtual object is too large relative to the movement of his hand, he presses the smaller button on the handle, and then the virtual object is set to the original position, and the system uses the dichotomy method to generate a smaller gain, and vice versa. The user manipulates the object again using the newly generated gains, and repeats the above process until he feels that the motion of the virtual object is consistent with the magnitude of the motion of his hand. The figure shows the scatter plots of the maximum and minimum values of manipulation gains collected through the above experiment. The maximum and minimum translation gains are 24.68 and 0.045. The maximum and minimum rotation gains are 5.33 and 0.053. The maximum and minimum scale gains are 5.89 and 0.057. We design an experiment to explore the relationship between the visual metrics and manipulation gains. The task is to ask the user to adjust the gain during manipulation multiple times until he feels the most appropriate gain. Start with initial gains generated by averaging maximum and minimum gains of the last experiment. If the user thinks the current gains are small or large, he presses the reset button to put the object back to the starting status, increase or decrease the gains, and then manipulate the object to the target. This process is repeated until the user thinks the current gains are appropriate. The user presses the reset button and then presses the save button to save the current gains and the object target visual metric corresponding to those gains. Based on these collected data, we derive the 3 fitting functions for visual metrics in translation gain, rotation gain, scale gain. We designed a user study with a manipulation task in 3 scenes to evaluate the efficiency, accuracy, task load of our method. There are 4 control conditions and an experimental condition. Here are the visualizations of the translation gains for 5 conditions during the manipulation. If the manipulated object is far away from the target position, a translation gain greater than 1 helps the user quickly move the object to the vicinity of the target object, thus improving the manipulation efficiency. If the object and target are very close, the translation gain should be less than 1. Which is particularly useful for improving the accuracy of manipulation.